Hello everyone, welcome to Calsoft webinar series and thanks for your participation today. The topic for today's webinar is aligning storage for virtualization. We're waiting for the rest of the attendees to join in, so we'll just give them 2-3 minutes to join in. So please wait on the call. Alright guys, welcome back. Brief introductions for the speakers for today's webinar. I am Mandar Sarvi, your moderator for today. I'm an engineering manager at Calsoft, delighted to be here with you for this webinar. Our speaker Tushar Tarkas is an architect at Calsoft who has extensive experience in the virtualization domain and has developed virtualization solution for multiple storage vendors. So before we start with the webinar, some information about how this webinar is structured. We have a presentation for about 40 minutes and about 10 to 15 minutes reserved for the question and answers at the end. However, we encourage the participants to post their questions through the presentation in the chat window, which I can collect later and we can get Tushar to answer them at the end. And we'll also be running some polls, so request you to participate in that also. Handing over to Tushar to take it forward.
Thanks Mandar for the introduction, and thank you all for taking out time to attend this session. As part of my job at Calsoft, I've been working with various product managers, architects, data center administrators in storage industry over the past few years for designing products to provide better integration in virtualization platform. The intention being very simple, to bridge gaps in overall storage management process in virtualized infrastructure. In today's session, I'll be walking through various business functions a storage administrator plays in an enterprise class data center, followed by how a VM-aware storage allows him to do more. The intention of this webinar truly is to highlight advantages of VM-aware storage in virtualized data centers. But before we begin, let me ask an open question to you, all of you. You can find the question in your poll window. For those who have logged in through audio only, I'll read out the question. Which of the following are current problems in your data center? Is it too many terminologies to understand, like LUN, volume, share, multipathing, virtual machine, logical file system at hypervisor, RAID levels, etc.? Is it manual bookkeeping of LUNs or shares to virtual machine? Is it difficulty in getting VM granular performance metrics like IOPS, latency, throughput, etc.? Is it storage being blamed for problems in the infrastructure? Or is it difficulties in setting VM level RPOs and RTOs? Although some of these problems may not directly surface to administrators, but they surely are part of problem statement of products or solutions designed for such infrastructure. Alright, I already start seeing responses for this, and in my poll window I see the highest ratings are the ones for manual bookkeeping of VMs and difficulty in determining the performance metrics for virtual machines. So these are some of the problems which storage administrators face day in and day out in typical data centers. Right? These days, if we see, virtualization has dramatically improved the efficient use of computing resources, often allowing processor cycles and memory to be provisioned or adjusted for any workload on the fly. With virtualization, the granularity of operations has moved from hardware resources to virtual machines. For example, CPU cycles and memory allocation can now be adjusted for virtual machines with sliders in management dialog. Traditionally, in enterprise class data centers, storage is provisioned using SAN or NAS technologies. If we look at traditional storage, LUNs and volumes have almost nothing to do with VMs. In modern virtualization, server resources are managed separately from storage, and this has led to a disconnect in virtualization management. Virtualization in its core behavior breaks the storage assumptions of one-to-one mapping between storage level granular object, which is LUN or a share, to virtual machines. Just to give an example, a LUN exposed to physical environment is typically consumed by a server, whereas the same LUN exposed to virtualization environment can now be consumed by multitude of servers. This also means that LUN can easily become overwhelmed with simultaneous I/O requests from constituent VMs, along with supporting tasks like snapshots, replication, performance monitoring, quality of service requirements, and so on. This is sometimes referred to as the very well-known I/O blender problem. In this session, I'll try to uncover a few of these high-level business operations a typical data center administrator troop performs. We'll walk through common data center use cases of storage lifecycle management to highlight these requirements. We'll then see how the same use cases get simplified by using VM-aware storage. We'll take a 30,000 feet view of solution intended to transform a traditional storage array into a VM-aware array. Finally, we'll see how being VM-aware prepares a platform for transforming the storage into being application-aware. If we look at modern data centers, we would find use cases like server virtualization, VDI, dev and test, public and private clouds, etc. These use cases differ in solutions they provide to end users. These differences bring with them unique challenges for management and monitoring of the infrastructure. For example, a boot storm problem, which is common in a VDI environment, or a variety of SLA demands across tenants in a multi-tenant public or a private cloud environment. Amidst these specific challenges, a storage administrator faces some common challenges on the management front. The challenges are spread across the areas of provisioning, monitoring, SLA management, backup and recovery configurations and operations, and last but not the least, capacity and workload management. If you take a look at typical data center topology, the landscape of products and the landscape of products used, at the bottom we see a hardware layer where we have the typical hardware provisioned in the form of compute, networking and storage. An administrator working at this layer is involved in deployment and setup of hardware. We're looking at a data center with multiple racks, with fiber interconnect, complex SAN NAS network, power and cooling options, etc. Some of the industry standard products in this layer would include compute nodes like Dell, IBM, HP, networking devices from companies like Cisco, Juniper, etc. or converged infrastructures like Nutanix, SpringPath, Cisco UCS, and of course, uh, not to mention the one in the context of this webinar, category of storage appliances including and not limiting to EMC, NetApp, HDS, Tintri, Nimble and the likes. Most of the products come with varied capabilities. Now these products expose northbound management interfaces for configuration and management. The interfaces include custom CLIs, REST or SOAP-based web APIs, GUIs. Some of them also support standard protocols like SNMP, IPMI, SMASH, SMIS, etc. Management products which perform a lot of operations for storage administrators consume these APIs to provide higher level functions. In the next layer, which is the infrastructure services layer, whose main function is managing the core infrastructure, an administrator typically performs operations of provisioning compute, network and storage for virtual machines, setting up virtual machine groups based on applications, tenancies, SLAs, etc. Now, if you look at a product map in this layer, typically the product provides necessary interfaces to administrators for doing their day-to-day activities along with aggregating and collecting information regarding health, performance, and providing interfaces to manage these appliances in context of virtualized environment. Depending upon the virtualization platform, the products used may vary. Typical products in this particular category include vCenter Server if it's a VMware kind of infrastructure, and SCVMM for Microsoft Hyper-V kind of infrastructure, Cisco UCSM or the likes of Nutanix Prism. All of these products provide pluggable mechanisms to bubble up hardware specific features. These products along with their respective plugins form tools required for achieving the business functions for an administrator. Next in the hierarchy is the orchestration and operations management layer. Now, this layer includes higher level functions which are specific to virtual machines or applications. Here, administrators worry about maintaining the overall health of infrastructure, maintaining compliance and security, configuring data protection policies, customized for virtual machine or applications or tenants, ensuring optimum utilization of resources by means of preemptive capacity and workload management, and so on and so forth. These functions require aggregation of data from layers below. It also requires tight integration with layers below to accomplish enforcement of certain policies. Admins achieve this function using solutions in these areas, which include and are not limited to semantic net backup or ActiveFORD or DUA for backup and recovery, VMware SRM, VM, etc. to achieve DR, HA, CA, compliance and security maintenance using products like high trust HTA, network monitoring and filtering solutions like Exia Phantom, WAN optimization products like Riverbed, and bunch of solutions for monitoring infrastructure like VMware VRO, Microsoft SCOM, Splunk, LogInsight, etc. These tools together create a complex mesh of interlinked configurations, policies, etc. Important to notice is all of these products and solutions base their operations on virtualization granular unit, the virtual machine. In the following sections, we'll see some of these IT functions in slightly more details, purely from a storage perspective. Let's begin with a very typical function of a storage administrator, which is configuring virtual machine and deploying applications on top of that. I may be a little off here from the way it's done in real world, but the operations for a storage administrator would more or less remain the same. If we consider provisioning a storage for setting up a group of interdependent applications, if we take a simple example like Microsoft Exchange server connected to an SQL server, we'll deploy these applications on separate virtual machines. A storage provisioning requirement for these virtual machines will require basic operation of provisioning storage of given size. Since the VMs are running critical applications, there will be an additional requirement to satisfy SLA demand in the form of minimum supported IOPS or maximum allowed latency, etc. Having a conventional SAN NAS multi-tiered storage solution, a storage administrator resolving such requirements will typically configure a large size LUN or a NAS or SIP share meeting the SLAs and provision it to the hypervisor with necessary redundancy in the network. SLA requirements, once configured, may not be defined only by the workload running on the virtual machine, but may also vary across tenants and compliance policies. Moreover, these may not remain static throughout the life cycle of a virtual machine. If we take the example that we just created and add a SharePoint server application using the same SQL DB server as backend, the SLA requirement for the VM running SQL DB server will change. To achieve this, the admin will either need to change the SLA of a LUN or a share or migrate the SQL server VM to another LUN or a share. Taking the first approach will essentially reflect in changing the SLA for all other virtual machines since all of them were present on the same LUN, which certainly is not a very desirable operation to do. Thus, storage administrator may think of a possibility of migrating this virtual machine to a different LUN or share which meets the required SLAs. Now consider the number of applications that a typical storage array, a typical storage administrator in an infrastructure would be handling. Now with the variance and growing variance of required SLAs, resolving each virtual machine to a different LUN or maybe a group of virtual machines to LUNs with different SLAs may not be a scalable solution at all. You might have noticed an added overhead of bookkeeping of VMs to LUN mapping which the administrator has to own now. Thus, provisioning a virtual machine involves a lot of planning, not only in terms of demands from storage, but also in terms of the sheer compliance and policies that resolve around applications. Depending upon the size of data center offerings, the number of virtual machines with such complex provisioning may also be large. Needless to mention, all the storage configurations related to access, SLA, etc. are performed on storage entities which are either a LUN or a share. If we take the same story ahead, once provisioned, these virtual machines or applications will have to be monitored for performance and compliance. One of the problems administrators have to solve is to troubleshoot performance bottlenecks observed in applications running on these VMs. While VM level performance statistics for compute and a network are somewhat readily available from the hypervisor, for storage statistics, admins more or less rely on the stats provided by hypervisor and underlying storage subsystem for getting the performance data. The information retrieved at hypervisor will be end-to-end performance for a virtual machine, while the storage arrays will provide a learn or share related statistics. Now this precise disconnect adds complexity in troubleshooting the performance bottlenecks for virtual machine. If we get back to the application we created in our previous step, identifying the problem of why an exchange server is behaving slow is a big problem in itself. To be able to even get to the storage statistics, the admin has to refer to the mapping between virtual machine and its provisioned learn or share. Now the difference in conventional storage is granular object, which is either a LUN or a share, and the virtualization system's granular object, which is a virtual machine, alleviates the performance monitoring in problem in a virtualized environment. If we take the third basic use case of backup and recovery, the data center story has a next beast to worry about. Data protection comes in various forms like HA, CA, DR, local and remote backup and restore, etc. As we all know, the products designed to achieve data protection either work at hypervisor layer using the snapshot and change block tracking mechanisms, or directly at a storage layer utilizing the native snapshot, clone, or replication mechanisms. Now, both these technologies have their own advantages and disadvantages, but one thing which is common amongst them is their basic unit of operation is either a virtual machine or an application. A storage appliance providing native features of snapshot or clone for learn or share will provide very little help in achieving complex requirements of data protection in a typical data center environment. The requirements for these solutions are governed by RTOs and RPOs defined at virtual machine or application level. If a solution needs to make use of basic snapshot, clone, replicate features provided by the storage appliance, then it needs to keep track of virtual machine to learn mapping itself. If we take a route of utilizing storage level operations, taking an application consistent backup of applications residing on different virtual machines, which in turn could be deployed on different LUNs, involves coalescing all the virtual machines, followed by taking a storage level snapshot of all the LUNs, and all of this at the same point in time. If we can think ahead, adding to this is a complexity of having such application clusters deployed in a multi-tenant environment. In our overall discussion, what we just saw are three very basic storage administrator functions and associated problems. Now, most of these problems arise out of basic difference in granular object in virtualized environment and conventional storage. A quick summary of the problems that we just saw is on a provisioning front. It's about keeping the mapping of VMs to learn or a share. Working with restrictions on per VM SLA due to the learn or share level granularity. Working around the scale limitations. Finding solutions for restrictions on per VM performance analysis due to learn or share level granularity. Perform tedious and time-consuming activities in troubleshooting the performance bottlenecks for virtual machines or applications, and working with limitations in supporting different RTO RPO policies for VM or application level granularity. If we all acknowledge to these problems, then we can take a look at what VM-aware storage brings to the table. Before we get into this discussion, let's spend some time on what does being VM-aware mean from storage perspective. At the core of it, it really is understanding the virtual machine boundaries within LUN or share boundaries while reading or writing the data. Storage arrays that achieve this pose themselves as VM aware. As a result, the array can now provide its basic native operations like provisioning, monitoring, data protection, etc. at a virtual machine level. Results: simplified provisioning, monitoring, data protection. The array now becomes more tuned in to virtualized environment. Let's see how some of the use cases that we just discussed with a conventional storage array get changed with a VM-aware storage array. If I talk about provisioning and consider the same application cluster we had created some time back with the conventional storage array, We had an Exchange server application running on a VM backed by SQL DB server running on another VM. Now both these VMs were provisioned on the same LUN or share. The difference with VM aware storage would be in the way SLA is configured for these VMs. The storage array being VM aware, the SLA will be configured for the VM itself rather than for the entire LUN. The change request for SLA for a given VM would be handled without affecting any other VM deployed on the same LUN or share. The result is extremely simple. VMs with different SLA requirements can now be deployed on the same LUN or share. Change in SLA requirements can be handled really easily, and very simply no need of VM migration to meet different SLA requirements. Take example of performance monitoring. Since the array is now capable of providing or since the array is now capable of understanding the virtual machine boundaries, it could provide performance metrics for virtual machine. Correlating the compute and network metrics with the storage metrics gets simplified a lot. Result is simple troubleshooting of problems, identifying the bottlenecks throughout the virtualized environment. Along with this, an admin can also take a look at similar metrics for other VMs deployed on the same LUN or share and easily detect problems like noisy neighbor in the infrastructure. Bubbling up these metrics for analytics to other applications also become easy because their uh, core of granularity is now virtual machine in place of LUN or a share. Backup and restore, again, policies can now very easily be configured at a virtual machine level, allowing the applications or solutions to directly invoke storage level APIs or storage level interfaces for configuring complex RTO and RPO policies based on the application criticality or the virtual machine criticality. To summarize the advantages, we just saw how we got rid of bookkeeping for VMs to LUN mappings, how we could very easily set SLAs on per VM basis rather than on a LUN basis, uh, the advantage of provisioning any number of VMs on the same LUN or share and get the VM level storage features, eliminates the problems of creating large number of LUNs or shares, improvement in identification and troubleshooting of VM-centric performance issues due to availability of VM granular monitoring data, identification of noisy neighbor problem becomes easy, VM granular storage operations simplifies backups and recovery workflows, ease of grouping VMs depending on applications or data sources for taking backups or for executing recovery workflows, utilizing storage level operations for performing backups and recoveries would definitely save time and management costs. Now, acknowledging these advantages, let's take a look at one such solution, uh, and let's take a 30,000 feet view of one such solution, which is intended to achieve VM awareness in a conventional storage. It's a solution from VMware, the VMware VVOLs. There already is a lot of discussion in industry about the advantages and disadvantages about this solution. But for today's discussion, we'll limit it to a very simple how part of it. If we take a look at VVOLs, VMware Virtual Volumes is nothing but an integration and management framework in vSphere that virtualizes SAN, NAS storage arrays for efficient operations which are VM-centric and not LUN or share-centric. Think of it as a bridge between virtual infrastructure admin and a storage admin. The solution is composition of storage array level software components and vSphere software components. Together, it transforms SAN NAS based storage arrays into VM aware. Following are high level benefits of VVOLs. First up, it's simplified storage operations. Storage operations like provisioning, monitoring get simplified as a result of tight integration between ESXi and a storage array. It also provides finer controls at VM level with storage services like snapshot, clone, replication, QoS, etc. working at a VM granularity, which in turn increases the control of VM level operations. It certainly improves the resource utilization by enabling more flexible consumption of storage resources when needed with greater granularity. The precise consumption of storage resources eliminates over-provisioning to a lot of extent. Improved efficiency in operation. VVOLs also comes with storage policy-based management with support for VVOLs. Enabled storage array opens up whole new way of doing storage management using policy-based profiles. Admins can now define profiles and associate it with required VMs. The underlying infrastructure of VVOLs takes care of making necessary storage configurations. This, in turn, largely improves the efficiency in overall storage related operations. This slide here talks a very high level architecture of how VVOL's solution is arranged. From bottom up, the basic components of VVOL framework it comprises of something called as storage containers. It has protocol endpoints, a VASA provider, and a vSphere SPPM. Out of these four components, the storage containers and protocol endpoints are part of storage array firmware. The VASA provider may or may not be implemented in the array framework. The last component, which is vSphere storage policy based management control, is a control plane module. This is the engine for storing and executing the template based policies. Now, this module is part of vSphere. With VVOLs, the concept of LUN or share is not used anymore. Instead, the VM's data files or VMDKs are stored directly on storage array. This eliminates the process of creation of logical file system. The VMDKs of VMs in case of VVOLs are essentially termed as virtual volumes. A VVOL enabled storage array stores these files directly into the storage containers. Storage containers are nothing but logical storage constructs for grouping of these virtual volumes or VMDKs. Storage array has to support defining one or more storage containers. The storage containers also serve as a storage pool for ESXi host to which they are exposed to. They are presented as data stores to the host. An ESXi host can thus create VMDKs or VVOLs directly on the storage containers. Storage containers are typically used to logically partition or isolate VMs with diverse storage needs and requirements. It can be accessed by multiple protocol endpoints. We'll see what protocol endpoints are in a while. It can be used for creating or exporting different capabilities for storage. Example, on a single storage array, a storage admin can create two different containers, call it gold and a platinum, and configure various different storage level services to these storage containers, which could include something like snapshotting, replication, or as simple as setting up different QoS policies on them. Storage array needs to provide the storage container features by implementing the VASA APIs. Now with storage container implementation, the array is actually ready for storing the data. For providing unified way of accessing the data, it needs to implement something which is called as protocol endpoint, referred to as PEs in the diagram. A PE essentially is an access point for multiple storage, serves as one connection for multiple storage arrays. These are discovered by ESXi host in its scan, and it also supports storage protocols like iSCSI, FC, FCOE, and NFS v3. At any given point in time, a PE can support one protocol, so that's something to notice about. It also takes care of zoning, multipathing, and things like that. Now with storage container and protocol endpoint, what we have established is a mechanism of connecting ESXi host with storage array at a data path level. Now these two components are data path components in the VVOLs framework. The other two components, which are VASA provider and SPPM, are the control path components. A VASA provider is a control path management entity serving storage capabilities which can be consumed by storage policy based management module included in vSphere 6.0. A VASA provider for a given storage array has to be registered with vCenter server. It enables out-of-band mode of communication between ESXi host and the storage array. As I said earlier, a VASA provider may or may not be implemented in an array firmware. There are ISVs who implement it in firmware and others who implement it in their centralized management applications sitting outside the storage array as well. Having looked at these three components, the last piece of puzzle is really the storage policy based management, which is the SPBM. Now this is the management layer of the VMware software defined storage model, which automates storage operations through a standardized approach that spans across the heterogeneous tiers of storage in a virtual data plane. It provides common management interface over VVOLs, vSAN, and other hypervisor-based data services. Essentially, it allows capturing storage requirements like capacity, performance, availability, etc. for applications in the form of logical templates called VM storage policies. By defining or adjusting policies, SPBM automates the provisioning process and enables dynamic control over storage service levels for individual virtual machines. Policies are also the mechanisms to automate monitoring and to ensure compliance of storage service levels throughout the life cycle of the application. Using SPBM and underlying VVOL's framework, an administrator can achieve finer control on overall storage management in VMware-based SDDC. Now, we just saw what advantages a VM-aware storage brings, and we just saw how one can transform a typical conventional SAN NAS based storage into VM-aware using one of the methodologies or one of the solutions provided by VMware. The advantages in both the cases essentially are the same. If we take the VM awareness one step ahead, let's see how the platform created for being VM aware aids in supporting application aware concept. With increasing adoption of virtualization for deploying and running applications, demand for providing storage services for specific applications is also increasing. Although the concept of application aware is not new, but it's recently started to pick up pace. As reading through one of the Tech Target blog, which describes application awareness for storage system as a system which recognizes application and is able to enhance its storage performance by improving the relationship between storage and applications, often manipulating the characteristics such as data layouts, caching behaviors, quality of service, etc. on the storage level. To some, application awareness also implies being content aware. VMware had published a technical journal which presents a solution called Application Aware Storage Platform. The solution brings with itself a complete platform which combines various components sitting within application at a guest OS level, hypervisor level, HBA level, down to storage subsystem. If we look at both the contexts, the application awareness requires storage subsystem or system to be aware of who is doing the I/O. The latter introduces terms of I/O hints or tags. Application awareness is not just a technology, but an entire system comprising of storage systems or storage management tools to support policies, allocations, configurations and use based on application use or service requirements and profiles. Conceptually, application-aware storage is intended to improve storage performance and storage service delivery and automate some of the manual provisioning processes that have routinely demanded IT knowledge. How is this related to VM-aware platform which we discussed some time back? The VM-aware platform brings with it increased awareness of VM boundaries within a LUN or a share boundary. This tunes the storage operations to be VM-centric. The platform can be extended to go a step further in identifying application data within VMware boundaries. The isolation of VM data in storage system can be used as a base for application data isolation. Furthermore, this base can be utilized for other storage services like snapshotting or replication to achieve application level SLAs. Advantages of this kind of system are obvious. The focus of these systems now shifts from just serving the LUNs or shares to the initiators or hosts to serving data for applications. Dynamic manipulation of data layouts, caching behavior and QoS levels can also be achieved. It also brings visibility to where applications map to storage resources. It enables policy-based assignment of storage customized for applications. Now, looking at all of these advantages and a few of the solutions, the main idea that I wanted to convey is a storage system being VM aware brings in itself a lot of advantages in terms of overall storage lifecycle management. It helps administrators at various different layers to basically get very virtualized granularity object centric data for performing a lot of operations which include and are not limited to uh, provisioning, monitoring, backup and recovery, SLA maintenance, and things like that. So with that idea, it brings me to the end of today's session. I hope there was a pinch of relevance to all of you folks throughout the presentation. I again want to thank you for your patience and time you have taken out to attend this presentation. Mandar, we can now start addressing the questions that are raised during the session.
Yeah, thanks, Tushar, for all those insights. So, one of the questions that has come up is, can something like VVOLs be applied to not only virtual machines, but also to physical servers?
So that's a very good question, but I think VVOLs predominantly is a completely VMware solution, and it has its footprint in at multiple layers within VMware as well, including the vCenter server as well as the ESXi hypervisor. So vWalls directly cannot be used for physical systems, but yes, a concept something like vWall can definitely be used here.
All right, thanks, Tushar, for that. We are open for any more questions if they want to send us across the chat windows. I'm just collating all the questions and we can take it forward. So meanwhile, just sending across the second poll, if you can participate in that, I'm just launching it for you right now.
Yeah, so we see another question here, and it's more from performance and monitoring area. So the question actually is, how does performance and monitoring get affected by how does performance and monitoring get affected if the data is provided at a virtual machine level or a LUN or a share level? So basically, it's exactly the same thing out there. So even during a performance and a monitoring, if I can take an example, let's assume we are in a VMware infrastructure and we're talking about we realize operations, which is a performance and a monitoring tool. So in this particular case, the core construct of the virtualization is virtual machine. If a storage system has information or performance data information available for LUNs or shares, um, the performance metrics that get collated or aggregated at a VRO level would be very much LUN and a uh, share centric data. Uh, what the administrator or a solution which is basically posting this performance data to the VROPs will have to do the mapping of virtual machines to these LUNs and shares to extract some relevant information out of it. Even after doing that, it might not be a completely relevant information because that LUN and virtual machine could be shared across that LUN could be shared across various different virtual machines. So that's the reason why if these statistics are available at a virtual machine level, having that kind of granularity helps identifying the performance monitoring.
So another question, Tushar, is any projections in terms of year-on-year cost of benefits of VMware storage?
Yeah, so I'm not completely aware of the numbers here, But definitely what we can do is we can come up with these numbers and get back to you.
So we can have one more question if anybody wants to ask, and then we can close.
Okay, see one more question. The question is actually, are there any disadvantages of VVOLs? Truly speaking, VVOLs as a concept is completely available to make administration and overall operations and management easy in a virtualized environment. So if you ask me what are the disadvantages of having a VVOL implementation in a storage array, if this particular storage array is not meant only for virtualization or VMware specific virtualization, then VVOL implementation doesn't really have a lot of value in there, because in a physical world there isn't something which is equivalent to VVOLs which would exist. Neither would there be a requirement so stringent for having something like that. Okay, see one more question there. The question is having a control plane separate and generic enough to support physical, virtual, or even application requirements is the way to go. Absolutely. It basically, as you've rightly identified, it's basically mating the control plane and the data plane perfectly, which works fantastic in getting what the desired results are. So if we can develop something which is equivalent, which basically works in both the physical and the virtual world, it could become a way to go. And you know nevertheless, the possibilities are unlimited, right? We can also think of having the application awareness built into the control plane as well.
All right, we are done with the questions, and Tushar, thank you for this wonderful session that you have done. We have been recording this session, and we'll post the links of the recording on our website, and we'll also email the links of the recording to you guys. Thanks for your participation, and we hope you found this webinar as relevant as we found giving it to you. Thanks a lot. Thanks, Tushar, once again.
Thank you, everyone.